Welcome to queenon7.com. Please like, share and subscribe my video. Today we're going to look at relative mass and moles. For this chapter I would actually request you please do not give up and wait for the whole video and learn it as much you can. If you have any problem, please wait for the following videos which are coming after this video, which will explain a lot more in details and you will understand all these topics in this chapter. Now, when we talk about relative mass and moles, you probably see a lot of videos on YouTube. I'm gonna make them very simple for you and very shortcut, so it will actually memorize over the period of time. When we say mass, a mass means a mass of any object. For example, 1 kg of bananas, or 1 kg of oranges and potatoes and all of that. So that those masses which we measure, we have a scale to do that. But in terms of atoms and molecules, they are so small that we cannot actually weigh them in a sense that we can't physically see them. So in that case, we have actually a standard form where we use a carbon, the mass of carbon, as standard. And I will explain that in a minute why. Now the mass is of two types. Number one, it is called atomic mass, and the other is formula mass. So we do understand mass, but we're going to explain the atomic and formula mass. What's the difference between them? Atomic mass means when you have only one type of atoms of the element in the sample. For example, if you have iron, or if you have sodium, you have oxygen. As long as you have only one type of atom, the mass will be represented by atomic mass. We also call it as relative atomic mass, and it is because it will be weighed against the mass of 1/12 of the carbon atom, which I will explain that in a minute. Now on the periodic table, when you will see that you have sort of some alphabets written on it, and you see some symbols Fe, some of them like NaO. All those symbols represent different types of elements. All those numbers has got a big number and a small number written on the periodic table. So if I will look at the periodic table, which you all are very familiar, looks like something like that. My handwriting is not that great, but that's how it looks like. It's not that, something like that. Now when you look at it, you will see like oxygen is somewhere there in group 16 or group 6 in the old periodic table. You will see two numbers on oxygen. That's how it will appear on periodic table. So oxygen will have two numbers, sodium will have two numbers, 1123, and iodine will have two numbers as well. For structure and bonding chapter, you always use a small number because that represents total number of electrons. For this chapter, we will be focusing on the big number. That big number is actually represents the atomic mass. So that means you do not have to calculate atomic mass of any element. All you have to do, you have to go back to periodic table and you can find that out from the periodic table. The problem which comes here when you're going to do a relative formula mass. Now relative formula mass, for example, you have sodium chloride, you have magnesium chloride, you have oxygen. When you have a formula where you have more than one atom involved into the whole molecule, it is called as relative formula mass. That what is the mass of this formula. Now it is pretty simple. What you can do is you can actually look at the big number written on sodium. What is the big number written on chlorine? What is the big number written on magnesium, and so on. So you go back to periodic table, you look for the atomic number of each element and you add them together. Right? Here I'm going to give you a small tip as well. When you look at these sort of elements where you have a small alphabet and a big alphabet there, if a big alphabet followed by another small alphabet, that is one type of element. So you are not going to look for only N, because N is nitrogen. If there is any small alphabet written after as a big alphabet, that is one element, and you look for Na on the periodic table. This is not D, this is Cl. So you look, C will be the bigger and L will be small. So it's actually Cl, one element. You're not going to look for carbon. So once you go on periodic table, you will see the big number, which is atomic mass, is 23 for sodium, and for chlorine is 35.5. All you have to do to find out the formula mass of sodium chloride, the relative formula mass is sodium 23 plus chlorine, which is 35.5, and the answer is 58.5 for sodium chloride. That is the mass of sodium chloride. If I talk about magnesium chloride, so let's take magnesium chloride. Magnesium, big number is 24, chlorine is 35.5. Magnesium is only one atom, so you write down 24 as it is, and then you will look for chlorine, which is 35.5. But there are two chlorine atoms, because this 2 actually belongs to this chlorine. It has got nothing to do with magnesium, so 35.5 will be times by 2. Right, so that's gonna be 24 plus 71, and that's 95. And that's how you're gonna calculate relative atomic mass and relative formula mass. Now, up to here is a lot easier. You can take so many examples. Or from a website, I've given so many examples there. It's pretty simple, but we're gonna look at what about the moles. What is actually moles in terms of calculating atomic mass and the given mass. Now, mole is like 1 dozen. So if I say 1 dozen of anything in the world contains 12 pieces or 12 particles, one dozen of banana, 1 dozen of oranges, 1 dozen of sofas, 1 dozen of TV, they all got 12 pieces in there. In chemistry, we call 1 mole of anything contains 6.022 10 to the power 23 particles. The particles can be atoms, it can be ions, it can be molecules. Right? It depends what you are dealing with. So what we can do is we can say, if I say 1 mole of hydrogen atoms, how many atoms gonna be there? So it is going to be 6.022 10 to the power 23. If I say 1 mole of hydrogen gas molecule, how many are there? I don't have to times it, because hydrogen H considered as 1 particle, H2 will also be considered as 1 particle. So it doesn't matter what size is of that atoms or molecule, as long as it's only 1 molecule or 1 atom, it will still contains same number of particles. I'm going to give you one more example. 1 mole of sodium metal contains 6.022 10 to the power 23 sodium atoms in it. And then I will take example of 1 mole of sodium chloride, and this time I will consider this as 1 particle. So what's going to happen is it will still be 6.022 10 to the power 23 sodium chloride atoms, sorry, molecules or particles in it. All right. So we can carry on all day. I'm just going to slightly change the example. If you say 1 mole, what about 0.5 moles of sodium chloride? Now this time you have cut the moles. I said 1 dozen of anything contains 12 pieces. Half of the dozen will contain 6. So if 1 mole of sodium chloride contains this much of sodium chloride molecules, 0.5 means half of them will contain 0.5 times 6.022 10 to the power 23 particles or molecules. So whenever somebody asks you how many particles are there. Your focus is to find out how many moles are there. Once you're going to find out the moles, you do know that 1 mole of anything contains 6.02 to 10 to the power 23 particles. All you have to do, you times with the number which you have got from the equation, put that in the value, and you will get the exact number of particles in that of the substance in the particular moles. Now, how we can calculate in exam? That's gonna be very easy. We're gonna look at the equation. That equation is going to tell you exactly how to calculate it. Now, the triangle is very famous for this, which means that you have the mass, and then you have moles, and here you have relative atomic or formula mass. You do know the relative atomic mass or formula mass can be obtained from the periodic table, so that's not a problem for you. So mass is represented by M, moles represented by N, small n, not big M, and the atomic mass is represented by AR or MR, and that's gonna be the atomic or formula mass. So we normally give AR or MR. So we can predict the, let's just say you have carbon. Now, because I said I'm going to explain what is meant by relative atomic mass, we do not have a proper standard scale because it's too small, so we can't have a scale. We do know the big number written on carbon is 6, so we're going to deal with only 6, which is the atomic mass. The scientist said the carbon has got the mass of 12 atomic mass unit. So 1 unit of carbon is equal to 1 unit of carbon is equal to 1 atomic mass unit, because there are 12 there. So if you take 12 pieces of carbon, 1 piece is equal to 1 atomic mass unit. Now it's just like 1 kg stone you put on one side of the balance, and you put the rest of the objects in there to see if it is 1 kg. So what scientists did, anything they have in the world, they actually measured against the 1/12th part of the mass of 1/12th part of the mass of carbon atom. Whichever is going to come against it, hydrogen comes equal to it. So the hydrogen mass is 1. Helium is actually comes at 2. So that was came at 4. So that is 4 is the atomic mass. So everything actually balanced measured against carbon, and that is one of the way to find out. But to cut the story short, for GCSE level, you do not need to worry about all of this. All you have to remember that the numbers written on the here, and helium 4, sodium 23, carbon 12, oxygen 16, all these big numbers tells you that how many moles are there. Now 1 mole, as I said, has got 6.02 to 10 to the power 23 particle. Let's just see the example of this. If I say 1 mole of this will have the same number of particles, and I say 1 mole of this marker has got same number of particles, 6.02 to 10 to the power 23 markers. Both have same number, but this one will be more heavier than the lid. So numbers can be same, but the mass can be different. So it goes same for these one as well. 1 mole of sodium contains, the number written on the top, so you can actually use that. 1 mole of sodium has got 23 grams. In the other sense, 23 gram of sodium has got 1 mole in it. Same goes for rest of them. 1 mole of chlorine will have 35.5 gram in it. But if I say 1 mole of Cl2, how much is going to be? As I said, it will still be 6.022 for both of them, but because here you have 2 chlorine and here you have 1 chlorine, so the mass will be higher in this one. All you have to do, you times the big number written by 2. So 2 times 35.5, and that is 71 gram. Let's just say 1 mole, more complicated, 1 mole of sodium chloride. How many grams are there? So what you can do is, you can say 1 mole is sodium chloride, this one is 23, chlorine is 35.5, so it's 58.5 grams in 1 mole. So it's pretty straightforward. All you have to do, you put the value and you get it done in this way. But I can give you even more simpler form, which will help you to understand how we're going to do it. Let's just take an example of the first one. 1 mole of sodium contains 23 gram. Use the equation and produce the equation. So you're going to find out the mass, which we don't know. So we will say N is equal to M over MR or AR. Rearrange that. M is equal to N times MR. Whenever they give you a question that find out what is the mass of sodium in 1 mole, all you have to do, you put N, which is 1 mole, 1 times, you go back to periodic table, look for the big number, MR or AR of sodium, which is 23, and you get the answer 23 grams. And that's how you predict it. So that's why I said I'm going to make it very simple for you, and you will be learning all of it with this triangle. If you remember the triangle, you will not forget it. So let's just take an example, and after that I'm going to finish. How many moles of carbon present in 12 grams? How many moles means you need to find out N, and you have been given mass, M is given. So the equation is N is equal to M over MR or AR, any one of them, doesn't matter. M is 12 gram. MR of carbon, if you look at the periodic table, which will be given, so carbon is 12, so 12 divided by 12, that is 1 mole. The answer is 12, this is gram per mole, the unit, so that's gonna be 1 mole. If I say question number 2, how many moles of sodium chloride are present in 20 grams of sodium chloride, I will use the same equation. N is equal to M over MR. M is 20 grams. MR is the addition of sodium and chlorine, so which is 23 plus 35.5 from periodic table. You will get the answer 20 divided by 58.5, and whatever the answer is gonna be in the moles. So they can ask you the different question like how much, what is the mass of carbon present in 2 moles. All you have to do, you have to use this equation, but rearrange that. M is equal to N times MR. In this case, you have N, which is 2 moles, 2 times MR. MR is 12 for carbon, so you put 12 there, that is 24 gram. Mass is represented by 24 gram.